Have you ever imagined a future where space travel is as simple as stepping into an elevator and pushing a button? This is the audacious vision behind the concept of space elevators, an idea that promises to revolutionize our relationship with the cosmos. Picture this: a colossal cable anchored firmly to the Earth and extending far beyond our atmosphere, reaching out to a counterweight suspended in the emptiness of space. Along this cable, climbers, vehicles designed for this unique mode of transport, ascend and descend, ferrying cargo and passengers alike into the great unknown. This concept, which may sound like something straight out of a science fiction novel, was initially proposed by the Obayashi Corporation in 2012. Their bold proposition posed a radical departure from the traditional rocket-based methods of space travel that have defined our exploration of the cosmos for over half a century. But it was a discovery made 2 decades earlier that made the idea of a space elevator a feasible concept rather than a mere flight of fancy. In 1991, scientists discovered a new material known as carbon nanotubes. These microscopic structures boast a strength-to-weight ratio far superior to any known material, a characteristic that makes them an ideal candidate for the construction of the space elevator's cable. However, as with any pioneering endeavor, the road to realization is riddled with obstacles. From the design of the cable and climbers to the protection against lightning strikes and radiation, a host of technical challenges stand between us and this revolutionary mode of space travel. The discovery of carbon nanotubes in 1991 brought us a step closer to this concept, but several technical challenges still remain. As we delve deeper into the fascinating world of space elevators, we will explore these challenges and the ongoing efforts to overcome them. For now, it's enough to marvel at the audacious vision that could transform our relationship with the cosmos and bring us one step closer to the stars. Let's delve into the technical challenges faced in the development of space elevators. The idea of a space elevator, a cable anchored on Earth extending to a counterweight in space, is a fascinating one. But the journey from concept to reality is fraught with obstacles, both foreseeable and unpredictable. The first hurdle is the cable material. The cable must be strong enough to withstand the immense gravitational forces and harsh space environment. Obayashi Corporation has been investigating the use of carbon nanotubes, or CNTs. These remarkable structures boast high strength-to-weight ratios, making them an ideal candidate. However, when CNT yarn samples were exposed to the space environment aboard the International Space Station, they showed reductions in tensile strength, hinting at the need for further material enhancements. Next, we have cable dynamics. The cable must remain stable under various forces such as gravity, centrifugal forces, and solar heating, to name a few. Obayashi developed a comprehensive numerical model to analyze these dynamics. The model can predict 3-dimensional motions and temperatures along the entire cable length, providing valuable insights into the behavior of the cable under different conditions. Then comes the climber design. These are the vehicles that will be traveling up and down the elevator cable. Obayashi considered 3 roller drive mechanisms and found that a simpler counter-rotating roller design requires less power and is less sensitive to cable tensions. They've already designed, manufactured and tested a climber model that successfully ascended and descended a 160-meter cable multiple times. Of course, there are other challenges too. Lightning strikes, energy supply, orbital debris, radiation protection, costs and legal issues all come with their own set of problems. But every challenge is an opportunity for innovation. Obayashi's research and development efforts are testament to the human spirit's unyielding pursuit of progress. The challenges are certainly daunting, but they are not insurmountable. With continued research and a dash of ingenuity, the dream of a space elevator could one day become a reality. Recent research has brought us closer to realizing the concept of space elevators. Scientists have been busy testing the viability of carbon nanotube yarn samples, a leading contender for the cable material. These samples were exposed to the harsh environment of outer space aboard the International Space Station. The results were intriguing. There was a noticeable decrease in tensile strength compared to the ground tests, but the Young's modulus, a measure of elasticity, remained largely unchanged. The visual observations revealed that the surface of the carbon nanotube yarn suffered some damage from atomic oxygen, a common element in space. However, the reattachment of carbon nanotube debris was also observed, providing hope for the material's resilience. Researchers are now planning further tests with coated samples to protect against surface damage. Another key area of focus has been the development of a comprehensive numerical model to analyze the dynamics of the cable. This model is capable of predicting three-dimensional motions and temperature changes along the entire length of the cable. It takes into account the effects of gravity, centrifugal and elastic forces, solar heating, atmospheric drag and lift, and interactions with the climbers. The simulations revealed that the transit of climbers can induce oscillations in the cable, particularly from the Coriolis forces. Temperature variations along the cable were also predicted to be quite extreme, ranging from plus 70 degrees Celsius to below negative 200 degrees Celsius over a single day-night cycle. As a result of these temperature-dependent material properties, the cable lengths and tensions also exhibited cyclic variations up to 300 kilometers and 10% respectively over different seasons. The design and testing of the climber model, the vehicle that will travel up and down the space elevator, is another significant area of progress. 3 roller drive mechanisms were considered, and a simpler counter-rotating roller design was found to require less power and be less sensitive to cable tensions. Double driving rollers reduced pressing forces and slippage substantially compared to single driving rollers. A prototype model of the climber was designed, manufactured and tested. It successfully ascended and descended a 160-meter cable multiple times during a competition, providing a proof of concept and a cause for optimism. Further improvements in efficiency are being investigated. So, while there are still many challenges to overcome, the recent research has made noteworthy progress in developing solutions for the cable materials, dynamics, and climber designs. The dream of building a space elevator is indeed a step closer to becoming a reality. These advancements represent significant progress in the path towards constructing a space elevator. The dream of a space elevator is still alive and well. The vision of a towering structure reaching beyond our atmosphere and into the cosmos is not just a figment of science fiction. It's a real, tangible goal that scientists and engineers around the world are tirelessly working to achieve. The ongoing research by Obayashi Corporation is a testament to this relentless pursuit of progress. They are pushing the boundaries of what we know about materials science, mechanical engineering, and space dynamics to overcome the remaining challenges. Among these are protecting the cable from lightning strikes, supplying energy to the climbers, dealing with orbital debris, ensuring radiation protection, and addressing legal and cost issues. The potential benefits of a space elevator are immense. It could revolutionize the way we travel to space, making it more cost-effective and accessible. Today, launching a satellite into orbit using rockets can cost up to $10,000 per pound. A space elevator could reduce this cost by a factor of 100 or more, making space travel affordable for more countries and private companies. Moreover, a space elevator could open up new frontiers for exploration and development. It could facilitate the construction of solar power satellites, providing an endless source of clean energy. It could also make the mining of asteroids with their rich deposits of precious metals a feasible proposition. Yet, it's not just about the economic benefits. A space elevator could inspire a new generation of scientists, engineers and astronauts, much like the Apollo moon landings did in the 60s. It could spark a renewed interest in space exploration and stimulate innovation in a wide range of scientific and technological fields. While the journey ahead is still long and filled with challenges, the future of space travel through space elevators is promising. As we continue to push the boundaries of what's possible, we inch closer to turning this dream into reality. And who knows? The day might not be too far when we'll be able to step into a climber and ascend into the stars, not on a rocket, but on a space elevator. The journey to develop a space elevator is indeed a testament to human ingenuity and perseverance. We've just delved into the complexities and challenges of creating a space elevator, a concept born from the minds of innovators at Obayashi Corporation. The hurdles are many, from finding the right cable material to understanding cable dynamics and designing the most efficient climbers. Yet advancements in the field, particularly in the use of carbon nanotubes, are steadily bringing us closer to making this ambitious project a reality. The journey has been marked by rigorous research and experiments, including those conducted aboard the International Space Station, and the development of comprehensive models to predict cable dynamics and climber interactions. Each step forward is a testament to our relentless pursuit of knowledge and exploration. As we continue to push boundaries and explore new frontiers, who knows? The dream of a space elevator might just become a reality in our lifetime. Thank you for joining us on this journey through the concept of space elevators. We've explored the theoretical foundations, delved into the technical challenges, and celebrated the progress made so far. Each step, each piece of research, each trial, and each error is a part of this journey towards a future that is as exciting as it is uncertain. Our exploration doesn't have to stop here. We encourage you to delve deeper, to keep learning about space elevators and other scientific advancements. The world of science is vast and ever-evolving, and there are always new frontiers to explore. What will be the next big breakthrough? What new technologies will we see in our lifetime? The answers to these questions are in our hands and in the minds of scientists, researchers, and innovators around the world. We hope that this video has sparked your curiosity and inspired you to learn more. If you enjoyed this content and want to stay updated on the latest in science and technology, don't forget to hit the subscribe button. We have more exciting and engaging content lined up for you. Remember, the future is always closer than we think. Thank you for watching, and don't forget to subscribe.